A couple of months ago, I had Bruno Sanchez on the podcast to talk about clay and foundational models applied to Earth. We talked about what foundational models are, how they work, and how they're developed. Well, today's conversation with Ben Strong is more about the so what. Ben works at the Earth Genome, and they've been building on top of these foundational models what they're calling the Earth Index. Rather than developing their own model, they're focused on the applications on top of it and what those could be. While the Earth Index is still in closed beta, you can request access if you want, but it's not open to anyone just yet. We talk about what these models mean for satellite image and map application and what they open up. This episode is sponsored by OpenCage. If you're building any application or tool that uses location data, at some point you'll probably need to convert place names or addresses into coordinates, or coordinates back into place names. And this is where OpenCage comes in. They offer a worldwide, affordable, forward and reverse geocoding service that's easy to use. OpenCage builds on top of open data sources, which grants much more lenient licensing terms than alternatives like Google, allowing you to store the data as you want and even keep it after you stop being a customer. You can also display it on any map, all at a more affordable price. OpenCage handles all the complexity of dealing with the messiness of the real world and provides a simple-to-use API that allows you to focus on your use case. They have a generous free trial that you can use to get started with no credit card required, and they offer a clear upfront pricing with a cancel at any time, no questions asked policy. To learn more, head over to opencagedata.com. I'll have a link in the show notes. As a side note, OpenCage is also responsible for hosting the GeoMob events as well as the GeoMob podcast, for which I'll also have links in the show notes. Thank you to OpenCage for once again being a sponsor and for their continuous support of the podcast. I don't know if you know, I like starting these conversations the same way every single time. I like asking people how they would describe themselves. So, quite curious, how would you describe yourself?
I think I would describe myself probably in a few different ways. I think like most people have a lot of different roles, a lot of different hats. I'm a scientist, got my PhD in geophysics. I'm an AI practitioner. I'm a dad. I'm a outdoors enthusiast and a lover of nature. And in the last couple of years, I've really been working hard to bring a lot of those different roles together. Actually, I'd argue all those roles together, including dad role. And as a developer of technology and building a new approach to how we can think about monitoring the state of the planet using AI and remote sensing data in a project called Earth Index. And that's been a project I've been working on as the science and machine learning lead at the small environmental nonprofit called the Earth Genome.
I really like that. I want to get into all of that and what it's like. In searching this, I found a blog post you wrote a little while ago about this idea that we need to have the equivalent of like DNA sequencing, but for the Earth.
Yeah.
I'd like to ask you to kind of walk me through what you wrote about. I think you wrote this about like 9 months ago at the moment we're recording this. So you guys have come out with the Earth Index. We're going to get into that. I'd like you to, if you could walk me through some of those ideas there and maybe some of the progress that you guys might have made since then.
Yeah, sure thing. Happy to walk through that. Thanks for reading my blog post, by the way. So like I said, I work at a nonprofit named the Earth Genome. And so clearly there's a metaphor there, an analogy to the human genome and DNA and genetics. That's actually been our name for around 10 years now that we've been a nonprofit. But I think that the name really has taken on new meaning in the last couple of years as we've been focused on applications of the latest kinds of machine learning, latest kinds of AI, particularly the kinds of large foundation models for remote sensing data, and how to apply those to the problems that we care about. So the basic premise behind that blog post was that we have, as a society, never had a better understanding of what is going on our planet through remote sensing observations, through primarily satellite sensors that are collecting data about the planet all the time. In the last 10 years or so, we've seen 7x in the number of Earth observation satellites that are orbiting the planet and collecting data on the planet all the time. That's a story of the public sector combining with new efforts from the private sector in order to put new sensors into space. And if you look at a plot of those number of satellites over time, it's really exponential, just as it takes off in the last decade or so. And with that abundance of information, we have the previously unthinkable abilities to just know what's happening on the planet anytime, anywhere. But despite all that, we don't really we haven't figured out the right way to unlock the value of all that data, right? We still have really big challenges when it comes to protecting the environment, protecting nature, dealing with climate change, all these big challenges. And so that's a bit of a paradox. Why is it that we have all this data and all this information, but we're not able to get the right tools in place, not able to derive the right insights, not able to derive the right impact? And the idea that I was playing with there in that blog post was driving that analogy for we need to develop an understanding of planetary genetics for the Earth. So right now, with the incredible amount of data that we're collecting about the planet, we have what I'd say is a good understanding of the phenotype of the planet. And apologies, is going to take us back to high school biology, perhaps. But the idea is that the phenotype is the outward expression of genetic traits, right? So that's something like eye color or height or something like that. That's an observable characteristic, an outwardly observable characteristic. And that's the kind of thing that satellite sensors are able to take an image of the planet and actually tell us what are those observable characteristics. But an understanding of phenotype alone doesn't solve all of the challenges of human health. And what we've seen in the last 30 years or so in the revolution around understanding of the human genome and the biotechnology revolution around genetics is that getting to that compressed essential representation of those observable characteristics through understanding of genotype allows for abundant innovation and abundant progress. So we've been able, through an understanding of the genetic sequencing of different kinds of cancers, we've been able to make more progress in the last 10 years than we've ever made in human history. So what is it that what's the analogy for Earth observation data, right? Where we have this complete understanding or a really comprehensive understanding of what the planet looks like, but how do we take it to the next level, and how are we able to distill it into something essential in order to be able to drive the next generation of technologies and the next generation of applications, and ultimately achieve those goals that we have, unlock the true potential of this imagery and data. And the argument that I've made is that we need to that the kind of genetic sequencing technology is being invented right now for remote sensing data, and that is very large AI foundation models that are capable of quite literally taking in all this abundant information and compressing it down into something essential, something that really looks a lot like a genetic code, by taking which is a foundation model embedding. And then by working at the embeddings layer, you're able to do all kinds of things much more quickly, much more innovatively, opens up all these new different possibilities. That Earth Index is one of those different applications that you can build on top of that embeddings layer in order to to do all the great things that you want to do. And so I think that we're really sitting at this moment, which is where it's a similar revolution in the ability to get things done. Where now we're going to be able to build on top of really large, really capable AI foundation models, extract the core meaning of input data as through embeddings, and then create interesting, really powerful tools on top of it. And that's the planetary genetic future of remote sensing data. And so I know there are a number of different components in there. I've already talked a little bit about this explanation. Happy to dig into any of those different components. But that's the high level overview of what that metaphor in that blog post is about.
So if I understand correctly, you are the approach you're taking is we were able to sequence DNA, and then we have genes, and first we just don't really know. Like, we just have all this DNA that's sequenced, but we don't really know what every gene does and like how it maps to a phenotype. But then slowly, like, because we have access to that, we're able to say, hey, this is the thing that defines the color of the eyes, and this is the thing that defines how tall people are. Maybe we find relationships between those, but it allows to basically unlock not just the expression of those, but like how they're all tied together. And so embeddings being the equivalent here for Earth, which is like just a lot easier to parse like every aspect, everything that we see on Earth. So that would be like, I don't know, forests or like where rivers are or something like that. But we have access to this much lower level representation of the entire world, the equivalent being like DNA and gene sequencing. Does that capture that metaphor properly?
Yeah, I think that's exactly right.
Okay.
Yeah, I think that when we first, as a society, decoded the human genome, we had no idea what it was going to be, how valuable it was going to be. Of course, we had an understanding that like getting to the genetic blueprint for life was going to have a real value, but I don't think anybody could have anticipated all the different applications that came out of that. And we're at a similar point right now where we have the ability to take all that data, compress it down, turn it into something new and different with a potential to build all kinds of new technologies and new tools on top of it. And by the way, like we've been doing this kind of something similar in remote sensing applications for a while, right? And I think that most people are familiar with things like NDVI, where you take an image and you extract a scalar value out of it that's useful for tracking things like vegetative growth over time. And what I'm talking about here is having a machine learning model extract that essential compressed representation in a self-taught kind of way, where we don't have to hand engineer those different features like in DVI. But you can think about an embedding as a multi-dimensional vector where each of those different dimensions represents something like in DVI, or something like tracking an element like around structure or even deforestation. And then being able to build on top of that opens up all kinds of new possibilities.
One of the things that I found interesting about your approach is what you've told me before is you guys are not building your own foundation model. I talked to Bruno Sanchez, who's working at Clay, and they're very much focused on the development of that model. So how do you take in all that data and you create those embeddings? And you guys are deciding purposefully to be after. So like you have those embeddings and you're after. Can you talk a little bit about that decision and what you're deciding to focus on then?
We have, we're really excited about the potential of foundation models, right? As you can tell. And we deeply investigated the idea of building our own, but ultimately decided that it wasn't the right fit for us. I think that there are a number of reasons that go into that. I think, first of all, the idea of a foundation model in its ultimate form is that everybody shouldn't have to build their own, right? The idea is that a foundation model is foundational in the way that multiple users should be able to derive benefit out of a single foundation model. And so we're believers that not everybody has to build their own, and we want to be able to build for that future where that is the case.
The equivalent would be like not everybody needs to sequence DNA all over again.
Exactly.
Like,
Yeah. No,
you
not
can
everybody
have
has to
right
build their own DNA sequencing technology. Right. No, it's enough for somebody to invent that once or twice, and they can perfect it, and then the rest of this increasingly segmented or this evolving value chain, players can play in different specialized roles, and that's really what the promise of the foundation model tech stack of the future is, right? Where you can have today everybody has to build their own model, but in the future, that's not really what I think is the goal of anybody developing a foundation model. And so that's just one reason. We just want to build for the future that we think is coming, right? The second reason is that I think that there are a lot of exciting ideas and a lot of exciting foundation models already under development and already published. But I think that everybody who works in the space acknowledges that there are pretty significant improvements and technical advances and big developments that still need to happen. And we're just not a nonprofit that's stocked full of AI researchers and folks interested in developing architectures and creating those innovations in the model development space. That's really something we're happy to leave to academia, happy to leave to folks like Clay, happy to leave to other ones who want to take those on and frankly take on the pretty big expenses around having those kinds of expertise in-house, and then having to train those models at scale, which is not cheap in order to spin up the big GPU compute cluster. But the most important reason that we decided to not build our own foundation model is that it's really just not where we see the most potential for impact, and not where we think that we are most interested in working. And so we're really focused on that gap between foundation models and impact. How do you translate the output of foundation models, which we take to be these embeddings, and how do you take those embeddings, this DNA genetic representation of the underlying remote sensing data, and translate it into something that's usable and used, and that is going to drive real decision making? That's where we have a lot of experience. It's where we have a lot of relevant expertise. And I think that that's where a lot of the really interesting questions lie as well. And so that's where we've decided to focus our efforts in the recent past.
Can you give me some examples of like what you're seeing as some of those applications, and like what does that work entails? How do you go from, okay, I'm coming back to your analogy. I really like analogies.
Yeah.
We've got the whole DNA sequenced. How do we go to, we're gonna. You were mentioning, you get better treatment for cancer, or you're able to understand genes related to certain diseases. Like that's the analogy for the genome. What does that look like for Earth, for remote sensing?
Yeah. I'll give you an example from the work that we're pursuing right now using Earth Index, which is this application that sits on top of embeddings in order to make the planet searchable and make environmental monitoring really quick and easy. And so that's a tool that we've deployed in a number of different contexts. I think that there are different lessons from different applications we pursued. But I think that the philosophy behind it really is that we want to be able to draw in the local expertise and downstream user as much as possible in order to have any data set that's created be relevant to that user. And we think that that's an opportunity that allows data sets to be more accurate and then more likely to be used, right? So it's not like we're not going to just be creating a data set and throwing it over a wall somewhere and hoping that you're going to use it. It's actually they're going to use it because they're creating it. For example where we've worked a lot on the problem of gold mining in the Amazon, where gold mining is a cause of deforestation. It's also a cause of human conflict. It's a cause of resource pollution, water resource pollution, particularly for indigenous communities and other vulnerable communities who live in the Amazon. And so these communities need to know where gold mining is occurring, but it's actually while it's one of the most studied applications of remote sensing, when you really get down to the local level, it can be a little bit challenging because gold mining in one area might not look the same as another area in the Amazon, and it might not. And having a locally fine-tuned model is really useful. So it's Earth Index. In one way to think about it is that that layer on top of embeddings on top of the DNA sequences that allows for rapid fine-tuning for that local context. And we put it in the hands of our partners who are either indigenous communities or close allies of indigenous communities. And what they've found is they've been able to build locally contextual, locally fine-tuned models in a particular region of the Amazon and discovered examples of gold mining they didn't know about, that they weren't picked up by other sources, weren't picked up by other models, and being able to have those examples surface through that locally fine-tuned process allowed for this higher quality data set to emerge. So that's one advantage of the approach.
Can you walk me through, like, how does that work in practice? Like, what are we talking about? I'm not sure I actually quite fully grasp. Like, when you're saying locally fine-tune, what does that mean in practice, and why? What is different from the previous iterations that means that you're able to pick up new locations that weren't able to be picked up before?
Yeah. Okay. From a technology perspective, so I guess there are two answers. There's the technology perspective, and then there's the user experience perspective, right? From the technology perspective, what is different is that we are building on top of embeddings, which, as we discussed, are these highly compressed representations of the underlying data. And the advantages of working on top of embeddings is that, and foundation models in general, is that you need much less training data in order to be able to get a high quality model. So that allows you to work in a mode that reduces the amount of time you need to collect training data and train these custom models. That's one advantage, and because if that opens up the door to do this local fine tuning, right? Because for local fine tuning, you often have a smaller data set. You have just whatever is available in this local region. And so that allows you to really just make sure that whatever data you're using in your particular model is relevant for this local region. Then from the other really the big strength of this approach is from that user perspective, in that by building on top of embeddings and by building on top of these shared pipelines, you're able to abstract away most of the complicated machine learning, the data science, the Python, everything, hide it behind APIs, and allow for downstream users to actually drive the modeling workflow. So in Earth Index right now, user can log in, select a region of interest, and drive that whole modeling process where they build a training set up from the ground up, where you can click on an example of a gold mine in your local region, say, this is what gold mining looks like to me in my local region, and then use that to start bootstrapping a data set that is used for that local fine-tuned models. And that's really the key thing here, is that being able to bring in a downstream user into the human in the loop iterative process of building a model allows for that user to bring in that local context, because they're the ones who knows what they're looking for rather than me. It's been amazing working with users who have a particular problem, and I think I know what they're looking for, and then they actually are clicking around and say like, oh, actually, this is an example of something else, or this is an example of more of what I'm looking for, and having that level of understanding brought into the modeling process really increases the quality of any results that come out of it.
I see. So the main value here that I'm understanding is you can have a lot less training data and you're looking for similarities. So you're asking people who have a deep understanding and knowledge of a certain area to point out, so let's say gold mining, and then because you have access to the embeddings, you can surface out very similar areas with a lot less training data than before. So it's very useful to discover similar areas, similar patterns across the Earth. Is that does that capture it well?
That's right. Yeah.
Okay. At the moment, you guys are still through a closed beta or alpha, or like it's still pretty closed, and you're deciding to give it access to a few people. How are you deciding like who you want to work with, and why take that approach compared to just like putting it out there and just like trying to like send it out to everybody and like getting as much input as you could?
I think that there are different levels to that. I think that there is some of this that we're excited to just put out there and see what users find, anybody finds interesting or useful. And so we want to be able to build an ecosystem around these ideas and share as much as possible in open source what we can, and be able to create enthusiasm around these ideas and approaches, and be opinionated about how they should be developed. And so there are things like some of the essential ideas around how to store embeddings that we've been contributing to, open standards about how to store and access embeddings, those kinds of things. And some of the input data sets that we've been using in order to generate embeddings themselves. So we just recently published a 30 terabyte data set of Sentinel-2 cloud-free imagery for 2023, which we're really hopeful. It looks like other groups who are working on foundation models are actually might pick it up and run with it and use it to generate their own embeddings, which is great. That's kind of the ecosystem we want to help flourish. Then there's those components that go into the pipelines and the supporting services and the ideas around standards. And then there's the application itself, the front end that we're developing in order to make searching embeddings and making modeling embeddings really easy and fast. And that's the Earth Index product that you can have, the users can have access to. And we have taken an approach to that we want to be just intentional with our development, where we're making sure that we understand where it's valuable, understanding where it's where it has potential to create new kinds of ways for people to work with data, and then build in that development. And so we don't want to rush too quickly. I guess we want to make sure that we're learning and iterating in a way that makes sense, and also want to make sure that we're protecting the users that we're working with, and that we're providing them with something that we know is going to work for them, and that is going to be supported for them in the medium and long term. And so we've taken an approach of having a set of initial users that we're really excited to work with. That includes indigenous communities and their close allies, data journalists, and then data scientists who maybe who do have geospatial expertise but don't have that machine learning modeling expertise. And just opening it up to a set number of those folks in order to see what they're going to do with it. What's exciting? What are some of the questions they're asking? What are some of the ways that they are able to do interesting new things? And then from learning from there, we're going to continue to iterate. There's a world where we open it up to anybody who wants access in the next year or so. We'll see where it goes. But right now, we're just trying to be intentional with our initial development.
Yeah, that makes sense. I'm excited to see where this could be used for journalism. I feel like I've talked to a bunch of people who've also been doing open source intelligence, on the podcast before, and it's still very manual in the efforts that they're doing in trying to find similar areas. They have one specific image, and they're trying to find where that image was taken from. Like geolocation is a very complicated problem that comes up a lot, or finding patterns of I don't know, like specific troops, something like that. Like I'm really curious to see how that might change how journalism is done on top of open data when people have access to. Basically, you're able to search. The closest way I think about this is like similar search on like Google Images. Like you upload an image
Yeah.
and it tells you, like, it finds all the similar images. Um, I'm very curious to see what that happens when you can do that with places and time, I'm guessing, as well. Um, so I'm
Yeah.
very curious to see, and I have quite a keen interest in seeing where, like, journalism and what kind of stories we might see come out of that as well.
Yeah, well, stay tuned. We have some exciting, exciting results to share in short order. We've been working with a number of really talented journalists who have taken Earth Index and ran with it, and it's been so fun to see how they're able to build out an understanding of a problem that they know exists, but maybe didn't know all of what remote sensing data can tell them, right? And then build out an extra level of nuance and understanding through interacting with data. So often, a journalist will think that they have an understanding of, like, oh, this is what, gold mining looks like, and I want to go find all this. And then they click on some gold mining and they realize, oh, but wait, there's this other kind of deforestation happening over here. What's the story with that? Let me dig into that and let me explore what that story is. And that can lead out that Earth Index is a tool for exploration rather than just set task fulfillment, is a really exciting idea that I think is particularly relevant for journalists.
I want to have a bit of a sort of a provocative question here. You talked about how earlier in the conversation we have all this data, and yet we still have deforestation and we still have a lot of these problems. And I kind of want to ask, like, to what extent is solving these problems just having easier access to data versus, people, like, we already know what, like, that there's a problem, but the incentives just aren't aligned. Like we know
Yeah.
that this is a problem. You can take a similar aspect to healthcare, for example. Like, there's a variety of things that we know are just unhealthy to do, and yet an enormous amount of people might still be smoking, or like there's this gap between, like, oh, there's the knowledge, and then there's the moment where before, like, okay, maybe you didn't know that something was harmful, and then it's harmful, and yet you might still keep doing it. um where do you think we sit on that? And, like, in a way, how helpful is, yet another tool? Again, this is a provocative question, but I want to hear your
Please.
take on it. Another tool to surface basically, like, images that we already have access to.
Yeah, I think it's a really fair question, really important question. And I don't want to pretend like I think that Earth Index is the panacea here. It's going to solve all of our problems. And I think that what is often needed is more effective governance or other kinds of structural changes in order to really drive change. And I think that that's a really important part of the conversation that needs to continue to be thought through. And we're making progress there, but is a big part of it. And so when you think about what Earth Index is, what the problem is that it's trying to solve, right? We're not trying to solve that whole thing. We're not trying to make it, not trying to solve the entire puzzle. We're just trying to solve a particular part of the puzzle, which is, how do we make sure that the right data is ending up in the right hands? And how do we make sure that translates into impact? And so we've been excited to see that it already is making a difference, or these kinds of data sets can make a difference. Some of the data that it's published through Amazon Mining Watch was picked up by by the federal police in Brazil and used in an indictment for a law-breaking mining company. There are things like that that make us think like we're onto something here. Definitely by putting this kind of information into the local stakeholders' hands who really know what they're looking for, who really know what to do with it, means that we're not going to end up wasting our time creating data sets
Right.
that aren't going to be used. That's really the key thesis there.
So you talked about Amazon Mining Watch, like you guys. So if we've talked about Earth Index a lot, but Earth Genome, the NGO, also works on a bunch of different other projects. How do you guys decide which projects you work on? Like I want to zoom out a little bit and go to, like how the whole NGO works itself. How do you decide this is going to be, we're going to start this new project called Earth Index because we think now is a good time. There's this alignment between there's more imagery than ever, and there's this advancement in AI. But now you have a new project that you need to develop and maintain. Like now you just have a lot more resources that you need to allocate. How do you guys decide which projects you take on, which ones you keep working on? Like if you go to the Earth Genome page, there's quite a
Yeah,
long
yeah,
list of different things you guys are working on. And so, how does that decision process happen?
yeah. Uh, we've been around for a while now. We've taken on a lot of different, really interesting, cool projects. But so we are a nonprofit, and our guiding light is impact. How do we make the most impact with the resources we have, the expertise that we have? And our expertise is really founded on data science, machine learning, and digital product design. How do we tie that all up into something that is a compelling experience? And that's led to a number of really great applications that have taken legs and taken flight. Things like Climate Trace, we're a core contributor to Climate Trace, which is this idea how can you do a grounds up emissions estimation for carbon emissions across the planet. Other projects like that, and also led to a whole bunch of projects around using remote sensing data and machine learning in order to track things across the planet. We developed this expertise around building watch applications, things like Amazon Mining Watch, things like Global Plastic Watch. And Earth Index really evolved out of that, where we had been doing things the old-fashioned way, where we said, this is how you build a platform around tracking gold mining, or this is how you build a platform around tracking large plastic waste sites that contribute to the 10 million tons of plastic pollution that end up in the ocean every year. How can we level that up into something that's more scalable and more useful? And so in a way, we were really solving our own problem. We decided we wanted to build this tool that allowed for general searching and cataloging of the planet in order to track things across the planet, in order to make that kind of production of the things that we were already building make make it faster and more accurate. And so it's been our general philosophy is that to just learn from experience. Where are we going to be able to make impact? What are the good partners to work with? Who have we succeeded with in the past? And then evolve. Say, like, this is where the technology is heading. We want to skate to where the puck is heading and try to anticipate that and build something new and different and innovative and impactful.
When I talked to Bruno Sanchez about like the development of clay, he had this line. I've heard him say this before, and I've heard like a few other people talk about this idea that what made ChatGPT particularly viral, in the sense like just everybody used it, wasn't the core model behind it. It wasn't like GPT-3. It was like the UI, the front end,
Totally.
where
Yeah.
you could just like I can send it to, and I have like sat my parents down and being like, all right, just talk to this thing, just whatever. Like, what do
Yeah.
you do at work? Just ask it a question. Like, what are you stuck on at work? I've done that with my dad. He was just like, oh, this thing that he's like super specific blocked at work, and he was like, let me ask it. And he actually like, I had to just go get some water because he wouldn't leave the computer, because it was like so easy to use. And I'm just hanging on to this idea because you talked about you guys are at the intersection of data science and then digital design, which I think is something that doesn't get like very much attention when like we can build these cool things. How do you go about building um, not just the data science, but the the usability aspect of whatever project? Like we can talk about Earth Index, but I this is really just a question about like UI and design and like how do you make things easy to use for people and like
Yeah.
useful for people?
Yeah. It is a big part of what we try to do. And I think that it's a unique skill set of ours and something that is maybe underappreciated. I love the example of ChatGPT. I think that, yeah, when it comes to like what is the most useful foundation model for mapping and for geospatial work, it's still GPT, right? It's not any other foundation model. This is because we all use it. I use ChatGPT almost every day in order to just like bounce ideas around and even help write code and all kinds of different things. And that really is driven based off of the idea that you can have a compelling user interface that sits on top of that foundation model in order to make things, make using that foundation model really easy and intuitive. And so that's exactly what we've been trying to build out with Earth Index. We're trying to reduce the barrier of entry in order to just make it as easy as possible in order to build things on top of it. And it's been fun actually. You said you sat down with your parents. I haven't sat down with my 2-year-old yet, but I have, one of our coworkers did sit down with I think his 13-year-old or something like that, and had his child run an Earth Index search, and they did great, and that was just so cool to be able to see that a child, or young adult is able to run a search like that and then be able to create interesting insights and come up with new questions about what they're looking at and dig into them and be able to explore them. And so I don't want to pretend like we've invented the chat GPT for remote sensing data or anything like that. I think that'd be a big overstatement. And that's something that is a pretty big thing to say. But I think that's the inspiration that we're taking for sure. We're trying to build things that are usable and that reduce barriers to access. As for our approach to doing that, I think that we are a really small team that's dedicated to that idea, and it's kind of baked into our DNA. And so we have a number of folks on staff that have a particular skill set and being able to work with users in order to understand their unique needs in order to be able to build something into the product, because it takes a lot of effort. I think it takes being really intentional about it. I think that sometimes groups can and have that design be an afterthought, or maybe that's too strong. At least not a top priority in a way that they are not focused on it. But that's something that we're really intentional about. It's every project we want to say, because this has to be an enjoyable experience to use. Otherwise, no one's going to use it. It has to feel good to use. That's one of the design principles of Earth Index. Is it has to be delightful. We use the word delightful. We wanted to make it delightful. So we made a little paintbrush interaction, for example, which isn't really necessary. It's not necessary at all, but it's fun to be able to paint things, as it's just more of an interactive experience of working with a mapping experience. So yeah, it's listening to user feedback and then just being really intentional about it, and then having the team assembled who has the right skills to do it, because it's not easy. I'm not a front end designer or developer, and so I'm lucky to be on a team that has that kind of experience and competency.
I want to ask you your opinion on something. I've had this thought that's been nagging me for a little while now. I've talked to, like earlier this year, I talked to Brian McClendon, which was the VP of Geo at Google, and he before that he was at Keyhole, and I went down a huge rabbit hole of Keyhole, and then the early days of Google Maps and Google Earth. And it's this wild stories that I just really invite people to go dig into if you want like a history of digital mapping. But what really stood out to me was like how far they felt like they were pushing the boundaries of what was possible at the time. And then whenever I talk to people about those conversations and some of the books that were written around that, most people, or at least a lot of people, tell me about, oh, I remember when like Google Earth came out or Google Maps came out and all the things that they went to look at. And it felt like this huge leap in just what you could do on a computer. And I've just been so curious as to why Google hasn't shipped this already. Like hey, just like in Google Earth, which
Yeah.
feels like it's just honestly, it's like a passion project. Like there's no use for Google Earth apart from this is freaking cool and we can do it. Like Google Maps is the real money making thing because it's tied to search. But there's something about like it's cool and we're going to do it because it's cool. And I wonder if it's just like Google isn't the company they used to be before. But I just imagine if they just dropped, hey, you can find, like, just click on a thing and we'll find everything that looks like it. Like, imagine the number of people who would be sharing that on Twitter and on LinkedIn and everything. Like, the amount of mind blown that you would create online is just huge. And the amount of use that they could tie into Google Maps as well, of like, oh, you like this place? Well, here's like 10 other that look just like it in every place that you want. Like the amount of interaction that they could build into Maps and Earth. Like I've just been so surprised that they
Mhm.
haven't done it. And so
Mhm.
I just want to share that thought and ask if you have any ideas as to why that might be.
Yeah, I think that you're not the only one who has expressed that thought, including me. Yeah, I think that it is surprising that there haven't been more attempts to do something like this at the product level that can do something um, that seems really delightful and interactive and fun and different. I think that you touched on some of the same thoughts that come to mind to me. I think that Google probably doesn't have the same necessarily the same approach to exploration of those wild ideas that it used to. But I can't say I'm not within Google these days. That could be the case. I think that there is a reason we decided to pursue this as a nonprofit, right? Like this, I think that there are companies doing similar things as for profits, but really what we're interested in is going after the use cases that are most connected to impact and maybe harder to connect to a venture-backed or large corporate scale business, right? And so I think the business model might just be a challenge. The final thing I'll say is that I think that I wouldn't surprise me if Google came out with something in this space pretty soon. They're full of really smart people and really great engineers, and are motivated to make things innovative and different and capture and create value where they can and within the boundaries of what Google as a company can do. I've had conversations on the sidelines of different groups, different events and meetings about whispers about what's being thought about over there and at different places. And so I think stay tuned. That's one of the reasons we're trying to put this out early, trying to think through what we think is the right approach and have an opinionated development here in order to influence their thinking and then maybe ultimately collaborate or figure out the right way to shape this ecosystem as we totally anticipate other players to enter and things to happen and this whole system to evolve. It's really at the early days of foundation models and what's possible. And it wouldn't surprise me at all if next week Google published their own big foundation model on remote sensing data. You know, Meta is already working with WRI in kind of a low key way in building a really powerful high resolution foundation model that they've used for canopy height estimation, but can be used for all kinds of different downstream tasks. And they just haven't really publicized it as much as I think they might have. And so there are these big tech players out there that are exploring and playing in this space. And it wouldn't surprise me if you'll have some updates and maybe a new podcast topic in a week, a month, or even just a week.
Oh man, that would be pretty cool. I think it's just this. I like what you're saying about, the difference between doing that as a nonprofit and just like, well, public company, or VC backed. The point on Meta, I think, stands. I think it seems like it's more about creating a data set that's useful. Like, I'm really just thinking like, oh man, I just want them to put something out that's just because, like, hey, because we can and it's cool. And like,
yeah,
it feels like there's many ripple effects of that. Like, you create people talking about your thing, you get a lot of people wanting to work there, which is like, maybe Google doesn't need that anymore. I'm curious to see what's gonna come. And maybe it's just like they haven't shipped it yet, and it could very well be, and we'll see in 6 months or a year where things are. Or maybe you're right, it's going to be in a week. Let's go on the I like talking about like how projects are funded. So it's an NGO, but you still need to convince people to basically give you money to work on these projects. um, what does that look like? Who are some of the, like, where does the money come from for Earth Genome? And like, what does that process look like of saying like, hey, we're not gonna spin up our own GPU clusters and create our own foundation model, but we're still gonna have designers and data scientists, and we need to host all of this. Like, there's still significant costs behind that.
Still significant costs behind that. You're totally right. Part of it is by working with partners who want to contribute their own expertise to what we're developing, and putting our limited resources behind the right task. That's like, for example, not deciding not to build our own foundation models. Part of that, right? Just saying like we have limited resources. It's how we're going to make things pencil out. For bringing revenue in, we've been really fortunate to work with some excellent philanthropic partners who have been great funders of this technology, but also great thought partners in helping us think through where applications are particularly going to drive the most impact. Organizations like the Rockefeller Foundation or the Patrick J. McGovern Foundation have been supporting us for a while now and have been really helpful in that respect. It's really awesome to have funders who are aligned with the kind of impact that you want to achieve, who are excited about the different users that we're working with and the kinds of impact that we're driving and having. It's been a really nice partnership with those organizations. I think we're lucky to be in a space where we're really clearly connected to impact, where we have those downstream users who are involved. That's the kind of thing that resonates with funders, just to, open up a little bit about how that process works. The other thing I'll say is that, for Earth Index in particular, but for all of our projects, we also do engage in fee for service work. So, we're not purely just philanthropically grant funded. We do some contracts in order to produce particular data sets or provide other kinds of services. And that is something that we're thinking through with Earth Index right now. I think we always want to make sure Earth Index is free and accessible to those users who we think can drive the most impact and who really we want to connect with, who aren't able to, who probably wouldn't be able to fund the subscription cost or something like Earth Index. But for larger corporations or for other groups that provide that will get some real value out of it, that can that would be willing to provide or willing to pay that subscription cost or something like that. That's something that we're exploring or thinking through different ways to have a business model around it. And that's something that we also have, I think is, it's important for just demonstrating the value that you're creating. There's no better signal than this, you're creating value for somebody than having them pay for it. Like that's just a really great signal to say you are developing something that's providing real value. And that's the risk that some nonprofits get themselves into, is that they build something that is really interesting or innovative, but doesn't necessarily, that people will applaud for, but it won't necessarily create really, the value that they hope. And so that's another signal that we're paying attention to.
That's pretty clever. Like I've heard people mention that, but usually they're like very for profit.
Yeah.
And it's like, yeah, that's true, but it's like very good to, like, it's a very fair point. Like, hey, you, in a way, you're not like shielded from like what people need. Like I hear you on this idea that like it's a very good signal. I'm just thinking about that.
Yeah, I think it's one of the cool things about being able to do this as a nonprofit. We can never generate a profit. We can never return any profit to shareholders or anything like that. And that's not our goal. And our goal is not to build $1 billion business. That's to build really $1 billion scale impact or whatever the analogy is, right? How do we do
what
something?
Even is an NGO today? You look at OpenAI and you're like, anything's possible.
Yeah. The OpenAI is another whole can of worms. That's hopefully we're sidestepping some of those issues by focusing on the problems that we're focusing on. We're not going to need to necessarily drive the same kind of huge scale revenue in order to support that massive GPU cluster.
Yeah. But I think like this is something I think about as well, is in a way the problems that you decide to tackle also define the structure and governance that you can have around them. Like you can't say, I'm going to go bootstrap a satellite image constellation company. Like unless you have some serious money from something else before, like it's just not going to happen. But if you say, in a way, like what you guys are doing, I think allows for, you just need less investment up front. Like back to, I was talking to Bruno and Clay, like that was a big challenge. It's like, yes, this is going to require a lot of money. And so I really think like whether you're nonprofit, for profit, like whatever project you decide to work on is inherently going to limit the options of funding that you can have. And like the smaller the upfront requirements are, the more options you can have on how you decide to fund a given project. And so, yeah, it's easy to make fun of OpenAI for like not being very open anymore. But on the flip side of that, if you want to build what they're building, like there might not be any other option than to just raise a huge amount of money, at which point like philanthropic is just not going to be enough. Like there's just not enough philanthropic dollars in the world going around, which is like a very weird thing to think about.
Yeah, definitely. Yeah, I think that choice of structure and governance is really essential and does drive flow to a whole bunch of different decisions. That I think that there need to be different approaches in different ways in order to see what works. I think we're really, and I think that I want to acknowledge that there are different ways to tackle these kinds of problems. We're really just excited about the ability to do this through a nonprofit, but kind of as an innovative, different nonprofit. We're small scale, or kind of like a tech startup. We're still trying to build digital products. And it is still a, like there have been new ideas around what does venture philanthropy look like, that kind of thing. Like and venture capital causes you to have, causes startups to make decisions about scaling to huge markets and making and neglecting the impact sometimes. But what we're trying to do still requires a good investment in capital and we want to be able to make that financially sustainable, then like those are some similar considerations, but because we're a nonprofit, we get to avoid, or we get to really focus on impact. I guess we get to really focus on impact, which is nice.
I feel like this is a nice place to start rounding this conversation off. So the same way I like starting with the same question, I like ending these conversation with the same question. I like asking for a book and a podcast recommendation. And so there's a couple of reasons I like asking for that is because these recommendations still travel a lot by word of mouth. I'm way more likely to read a book that someone told me was pretty cool, and even just to hear about it, and like even more for a podcast, because you still cannot go to a podcast store and just pick up a podcast as you can for a book. And the second is I just think it's a nice way to learn a little bit more about what people are interested. So if you listen to podcasts, is there a book and a podcast that you think people could just check out? Doesn't have to be about anything we talked about, just something you might have thought was pretty cool and worth sharing.
Yeah. I think there are lots of books and podcasts I'd probably recommend. There's so many great things out there to learn and explore and think about. I guess, like, what have I been listening to recently in podcasts? Well, as you know, here in the U.S., the American election's spinning up, and so that's been something on my mind. Nate Silver's back with his empiricist driven takes on the election. He has a new podcast called Risky Business, which is kind of neat, thinking through like risk quantification and empirical thinking and how it can be applied to all kinds of problems. And he obviously he's somebody who's been modeling the outcomes of elections based off of polls for a long time. So it's interesting to hear his thinking. So maybe that's one I think would probably resonate with your audience. Risky Business is the name of the podcast. Then for a book, let me think. Well, I recently moved to the southwest part of the state of Virginia, and so it's in the heart of Appalachia. Maybe we can have another podcast about this sometime, about this region. And it's a Roanoke, Virginia is the name of the city I moved to. It's a cool city. It's a place that's close to my heart. And a recent book that has really been popular in a lot of circles I'll recommend here is Demon Copperhead, which is by Barbara Kingsolver, which tells a story of a life in this part of the country, and is a really compelling read. Barbara Kingsolver is an excellent writer, and so I'll recommend that one.
All right, that sounds pretty good. Thanks.
Yeah, check it out.
Yeah, no, I appreciate it. Again, like, part of the reason I asked this is because I think it's just the coolest way to hear about new books and podcasts, and they're still like, they just go through word of mouth. So I appreciate this. I don't think I'd heard about either of these, so thank you.
Yeah. Let me know what you think if you check them out.
I have a long backlog.
Yeah, I bet you do.
It doesn't prevent me from keeping on asking people what they would recommend.
Yeah.
Ben, thanks so much for your time. I appreciate it. I appreciate the conversation. This was really nice. And I look forward to seeing what you guys come up with next.
Thanks so much, Max. It's been a lot of fun. Really enjoyed sitting down with you today. Thanks for making the time. Looking forward to following up with you at some point and sharing more about what we've been up to.
Hey, thank you so much for listening to this conversation. I wanted to take a moment to thank the sponsor of this video, but also all the people who financially support me on Patreon. If everything goes well, these conversations should feel and sound seamless and effortless, but there's a lot of work that goes behind the scenes. I try to research and prepare these as much as I can to know who these people are and what makes them interesting and what would lead to a good conversation. I'm incredibly thankful to all the people who support my work on Patreon, meaning I can do a little bit more of it. This podcast started out as a way to learn more about the people in this industry, but I've also started making educational content on another YouTube channel that I'll put a link to in the show notes. And I want to make more content explaining how satellite images and maps work to a broader audience, as well as continuing to research the guests for these podcast episodes. So, if you value the work that I do, I'd like to ask you to please consider supporting my work on Patreon. There's also some behind the scenes of how this podcast is done and some of the work that I'm doing for these educational videos if you want to learn more about how I do all of this. Either way, thank you so much for all of your attention and your time. I really appreciate it, and I hope you get value from these conversations. Thanks.